Welcome to EC Elimu, Learning Simplified, and welcome to this lesson. In the previous lesson, we looked at how a pinhole camera forms images on the screen, and we realized that an array from the tip of the object will move in a straight line through the pinhole and form the tip at the bottom of the screen, and array from the bottom or from the tail of the object will move in a straight line and form the tail of the object at the top of the screen, and the image which will be formed will be upside down. Now in this lesson, we are going to discuss how large the image will be than the object, or how small the image which will be formed on the screen will be than the object in what we call magnification. My name is Albert. I hope you will enjoy the lesson. By the end of this lesson, I expect you to be able to define magnification and then derive a magnification formula in terms of object height and image height, and in terms of object distance and image distance, and then finally solve some numerical examples on magnification. Before we define magnification, let's consider a pinhole camera in which an object of object height HO, this is the object height or the object size, is placed in front of a pinhole camera at some distance U, which we call the object distance. Then it forms an image on the screen of height HI, which we call the image height or the image size. Then this image is formed at some distance V away from the pinhole, and this distance we call it image distance. So we can use the idea of object height and image height to define magnification, or we can use the idea of object distance and image distance to define magnification. So if we use the object height and image height, we can define magnification as the ratio of the image size. Size, sometimes we call it height. So it is the ratio of the image height to the object height. So in this case, we can use that definition to write the formula of magnification. And we have said magnification will be equal to the ratio. Ratio means a division bit of the image height you divided by object height. So if you know the image height, in this case HI, you divide it by object height, which is HO, then what you will get is magnification, which means the extent by which an image is larger or smaller than the object. Then if we use the idea of object distance and image distance to define magnification, then we can define magnification as the ratio of the image distance to the object distance. And in this case, if we can write a formula for magnification here, it will be magnification is equals to image distance. Magnification is equals to image distance, or the distance of the image from the pinhole. You divide it by object distance. Remember, image distance is written as a simple V, and object distance is given as simple U. Object distance is given as simple U. Then in this case, we can say magnification as a simple M is equals to V divided by U. This is equation 2. And in the first scenario up there, when we defined it as an image height over object height, If we can write it as a simple, we can say magnification is equals to image height over object height. Now, since we have determined that magnification is equals to image height, which is hi, divided by object height, which is ho, and we have also said we can determine magnification as the image distance v divided by object distance u. Therefore, magnification in this case is the same as magnification here. Then it means image height to object height is the same as image distance to object distance. Then we will not be wrong by saying magnification is equals to image height to object height, which is the same as object image distance to object distance. Therefore, it means if you know the image height, then you know the object height, and then you know the image distance, then you can get object distance. Therefore, given image height and object height, and then you are given maybe the image distance, you can determine the object distance. And then if in this case you need object distance, you just cross multiply like this. Then it will be magnification. In this case, it will be hi times u, which is going to be ho times v. So if you need hu or you need u, then you will divide by hi on both sides. Then this one will cancel. If you need u, now it will be ho times v over hi. So if you are given any of the three quantities, then you can be able to determine the rest. Like in this case, if you need ho, then it will be ho. For you to get ho, then you are going to find it is going to be hi times u divided by v. So you can use any of this, you can manipulate this equation in any way to determine what you don't have, so long as you have any two quantities. So we are going to do few examples so that we see if we can be able to apply this formula. The first question here reads, a pinhole camera of length 18 centimeter forms an image 3 centimeters high of a man standing 9 meter in front of the camera. What is the height of the man? Now, since here you are told it's a pinhole camera, then you sketch the diagram of a pinhole camera. Remember, we said a pinhole camera has a screen where the image will be formed. So here, HI will be formed here, the image will be formed here, HI. Then the length of the pinhole camera is the same as the image distance, V. Then we have the distance where the object is placed in front of the camera, which we call the u, and then we have the image height, not the image height but the object height, which we call ho. Then now you start identifying the pinhole camera has a length. Now here the length of the pinhole camera is the same as v, 18 centimeter. Then it forms an image of height. Now the image height, which is hi, is 3 centimeter. This one is 3 centimeter. Then of a man standing in front of the camera, a distance in front of the camera, in this case it's u, 9 meter. But remember, 9 meter we are dealing, the rest of these are in centimeter. Then 9 meter, if we convert to centimeters, we'll multiply by 100, then it will be 900 centimeter. So our u here is 900 centimeter for the purpose of uniform units. Then they are asking, what is the height of the man? Now they need the height of the man who was acting as an object. So in this case, what you do, you write our formula for magnification. Magnification is equals to hi over ho, which is the same as v over u. So now what you do in this case, since we are not interested with magnification, now hi over ho is the same as v over u. Do we have hi? Yes, we have hi as 3 centimeter. Do we have ho? Ho in this case we don't have. That's what we are looking for. Then do we have V? We have V as 18 centimeter. 18 centimeter. Then do we have U? Yes, we have U as 900 centimeter. And now what you do in this case, you solve the one on the right hand side since it can be solved directly. Then we will remain with 3 centimeter all over HO is the same as 18 divided by 900, which is going to give us a 0.02. And since the units of centimeter will go with centimeter, so this number will not have a unit. Then in this case now, to get HO, for us to get HO, we will multiply by HO on both sides, multiplied by HO, multiplied by HO. Then in this case, HO in the left hand side will go. Then we will remain with 3 centimeter is equals to 0.02 times HO, which will be 0.02 HO. Now, if we need HO, then here it means we will divide by 0.02 on both sides, divided by 0.02, divided by 0.02. Then in this case, if they cancel out, if this one cancel 0.02 on the right hand side goes, then we will remain with our final answer as HO is going to be equals to 3 centimeters divided by 0.02. This one does not have units, then it means our answer will remain in centimeters. Therefore, in this case, our HO is going to be 3 divided by 0.02, which is the same as 150 centimeters. So the height of the man is 150 centimeters. And if you are required to write it in SI unit or to give it in SI unit, then you will divide it by 100 because 1 meter is equals to 100 centimeter. Then now if you have 150 centimeters, then now you will just do a cross multiplication and you will get the height of the man as 1.5 meter. So the height of the man will be 1.5 meter, or you can leave it at this point as 150 centimeters. Let's do another example. The second question here reads, a lamp of height 4 centimeter stand in front of a pinhole camera at a distance 32 centimeter. The camera screen is 8 centimeter from the pinhole. What is the height of the image? As we mentioned earlier, what you do, you sketch a pinhole camera here. This is the pinhole camera. And remember, we have the features of a pinhole camera. We have U, then we have HI, HO. Then on the other side here, we have HI, and then we have V. Now, do we have the height of the object? Yes, we have the lamp which is standing in front of that, of the pinhole camera, which is 4 centimeter. Then do we have U? Yes, this lamp is standing at 32 centimeters from the pinhole camera, which is 32 centimeter, that is U. Then the camera screen is 8 centimeter from the pinhole. This is the pinhole, the screen is 8 centimeter away. Then it means what we have been given here as 8 centimeter is V, 8 centimeter. Then they are asking, what is the height of the image? They are asking for that image height. So what you do here, since all the units are uniform in centimeters, then you write our equation, HI over HO is equals to V divided by U. Now, do we have HI? That's what we are looking for. So we don't have this one. Do we have HO? Yes. Do we have V? Yes. Do we have U? Yes. And now you feed them. In this case, it will be HI divided by HO is 4 centimeter is equals to V, which is 8 centimeter, divided by U, which is 32 centimeter. So in this case, you solve the right hand side here. Centimeter and centimeter will cancel out. Then we will remain with HI over 4 centimeter is equals to 8 divided by 32, which is the same as 0.25. 5. Since the units cancelled out, it will not have units. Then now in this case, for us to remain with HI alone, then we will multiply by 4 centimeter on both sides, 4 centimeter. Then in this case, on the left hand side, 4 centimeter will cancel out with 4 centimeter. Then we will remain with HI. HI in this case is going to be 0.25 times 4 centimeter times 4 centimeter, which is going to give us 1 centimeter. So the height of the image which will be formed will be 1 centimeter. And if you want to prove this, then you can equate the two. HI we have got as 1 centimeter divided by 4 centimeters, which is HO, is supposed to be equals to 8 centimeter divided by 32 centimeter. Now 1 divided by 4 is the same as 0.25. Then 8 divided by 32 is the same as 0.25. So in this case, the units cancelled out like this. Then you can see the left hand side is the same as left hand side is the same as the right hand side. So the answer that we have got is true, and you can even test yourself like that. So let's do the third example, and then I will leave the fourth one for you as an assignment. The question reads, an image 10 centimeter long. So this is image height of a man 2 meter tall. This means this is HO, the height of an object. The man is going to behave as an object. Is pinned on top of a pinhole camera. Determine the distance of the pinhole from the screen. So we are going to determine the distance of the pinhole from the screen. We are going to determine V. If the man stands 6 centimeter from the pinhole, so this is U, 6 centimeter in this case. So the first thing you do, you sketch the diagram for this pinhole camera. Then here, if you have the pinhole camera like that, we have been told the image is 10 centimeter. So the image here, which is HI, is equals to 10 centimeter. Then the man is 2 meter tall. 2 meter tall, it means that is the object height. Here we have HO, which is 2 meter. 2 meter converted to centimeter is 200 centimeter, or we can say 2 meter. Then do we have U? Yes, U is the distance of the man from the pinhole, which is 6 centimeter. Then what are we looking for? The distance of the pinhole from the screen, which is a V. In this case, we don't have V. Then if you write our formula, HI over HO is equals to V over U. Then in this case, do we have HI? Yes, we have HI as 10 centimeter. Do we have HO? Yes, 200 centimeter. Do we have V? We don't have V. That's what we are looking for. Do we have U? Yes, 6 centimeter. Then in this case, if you substitute, it will be HI, which is 10 centimeter, divided by HO, which is 200 centimeter, is equals to V, which we are looking for, divided by U, which is 6 centimeter. Then in this case, we solve on the right hand side. We can solve it. It is 10 divided by 200. Remember, centimeter will cancel out with centimeter. And now if you have 10 divided by 200 is the same as 0.05, which does not have units, is equals to V all over 6 centimeter. Then in this case, if we need V, which is the image distance, then we multiply by 6 centimeter on both sides. Then in this case, this 6 centimeter on the right hand side will cancel out, and then we will remain our V. We will get our V as 0.05 multiplied by 6 centimeter. So our V is going to be 0.3 centimeter that is the distance of the pinhole from the screen. So what you do, you first sketch the diagram of the pinhole camera, then you identify what you have. Like in this case, we have identified HI, we have identified HO, we have identified U, then we have identified what you don't have. Then when you substitute, then you solve it like that, and you get your V as 0.03. Then this one, I will leave it for you as an assignment. This is your assignment. You do it. If you get any challenge, be free to visit ECLimu. There's a link down there. And then you will get more questions like this and solutions only at ECLimu Learning Simplified. So that has marked the end of our lesson today. In the next lesson, we will discuss reflection.